We're going to talk about section 12.6, vectors and planes, and this will be the first video. So in space, in 3D, an equation of the form ax plus by plus cz equals d is a plane. To graph these can be a little tricky, so if we have something where all the coefficients are not zero, so x plus 2y plus 3z equals 6 is our example, we're going to find its x, y, and z intercepts. So to find an x-intercept, we're going to plug in 0 for the y and the z. Plug in 0 for y and z, and then solve. So when we do that, when we plug in zeros for y and z, we just get x equals 6. So that means our x-intercept has x coordinate 6, y0, and z0. Now when we go to plot these on our axis, remember the x is coming out away from the paper, I guess, and the z goes vertical and the y is going horizontally. When we make our tick marks on the x, we try to make them parallel to the y so that it gives you some perspective. So there's 1, 2, 3, 4, 5, 6, 0, 0 is going to be this point right there. So there is 6, 0, 0. In a similar fashion, to find the y-intercept, we'll plug in 0 for x and z, and that will give us 2y equals 6, which means y is going to be 3. So that gives us the point 0 for x, 3 for y, and 0 for z. So that means we're going to go on the y-axis. I'm going to make the tick marks now parallel to the x. So we have 1, 2, 3, and that's going to be our point 0, 3, 0. So there's our y-intercept. To find the z-intercept, we're going to plug in zeros for x and y, and that's going to give us 3z equals 6, which means that z is equal to 2, and that gives us the point 0, 0, 2. And the tick marks here just go parallel to y, so I'm going to go 1, 2, and then here is our point 0, 0, 2. Now, you're going to visualize this now. What we're seeing here is where our plane is intersecting the axis. So I'm going to draw, as I draw these, this line right here is known as the XZ trace. So that is the XZ trace. That's where our plane intersects the plane, the XZ plane, that thing that's parallel to the side wall. When I draw this, that's called the YZ trace. So that's the YZ trace. That's where our plane is going to intersect the piece of paper that you're drawing on. And then when I connect these two, that's the XY trace. That's where our plane intersects like the floor, that horizontal, that plane coming out parallel to the floor. So what we're trying to see is this thing is kind of leaning up against the corner of our axes there. So I don't know if I can erase it this late in the game, but this would kind of block out. That's too much. I don't know if I can do this. I don't think I have the resolution that I need there. But the idea is this is blocking from view what we see there as that plane lays up against that. Okay? So that's the first stage when we have the x, y, and z all have non-zero coefficients. So it gets a little trickier when that changes. So let's look at graphing here. So we're going to graph x plus z is equal to 2. So what happens when you're missing one of the variables? So this means that the coefficient of y is 0, and it's it's equal to something that's not 0, and the equation, being it, is equal to a non-zero number. So we're going to do something different when it's equal to 0. So what this means is when there's a missing term there, is that we're going to, our plane is going to be parallel to the missing axis. So it's going to be parallel to the missing axis. So in our case, since y is missing, our plane right here is going to be parallel to the y-axis. So let's see if we can kind of visualize what's happening here. I'm going to try to draw there's our z, here comes our x, there comes our y. So again, x, that's z, and that's y. So we're still going to find the traces, or the intercepts. So our x-intercept is going to be, when we plug in 0 for anything except for x, we're going to get x equals 2. So that's going to give us the point 2, 0, 0. So we're going to go out 2, and I'm going to plot that point right there, and that's 2, 0, 0. Then we're going to find it's parallel to the y, so it's not going to touch the y at all, but we will have a z-intercept that is going to be when we plug in 0 for everything but z, so z also is going to be 2, so we'll get the point 0, 0, 2. So I'm going to go up 2, and I'm going to put a point down there, and that's going to be 0, 0, 2. Now, I'm going to test your visualization skills here. Remember, our plane is going to intersect the XZ plane right there. So that is our XZ trace, and it's parallel to the Y. So if you can imagine, I'm trying to draw this like it's kind of leaning up against the wall there. So our plane is going to kind of come out here, and it's leaning up there, so you can't see. So this part of it in here, I don't think I can. So I'm trying to, this would not be visible. Hold on a second there. Okay, so this part, I keep touching it. I'm left-handed here, so I keep touching it here with my offhand. So this part would not be visible because it's being blocked from view, nor would that. I'm trying to kind of make it look like it's dotted there. You're going to have to try to struggle to visualize that. Okay, let's do another one here. So let's do, let's graph x equals 3. So in this case, we're missing both the y and the z. So this will be parallel to both the y-axis and the z-axis. That is, it's going to be parallel to the YZ plane. Okay, let's see if we can figure out what this is going to look like. Here's going to be our axis. Again, this is Z, that's going to be X, this is going to be Y. The only intercept we're going to get is going to be 3, 0, 0. So I'm going to go on the X, 1, 2, 3, making my tick marks parallel to the y-axis. Okay, now I'm going to try to draw a plane here that contains this point 3, 0, 0 and is parallel to both y and z. So I'm going to try to make this look like it's standing up, straight up, and coming across there. You're going to have to visualize that. So it's now, if you couldn't see through this, then the axes here would have to be dotted because they would be blocked from view. I don't know if that helps or not. Okay, I'll go to a new frame here. And so now what we're going to see is if the equation is missing a variable and equal to 0. So if the equation is missing a variable, that is the coefficient is 0 for that variable, and the equation, it being the equation, is equal to 0, then the plane will contain the missing axis. Will contain the missing axis. All right, let's see if we can figure this one out. So suppose we have the equation 2x minus z is equal to 0. So I'm going to draw my axes over here, and once again, that's going to be z, that's going to be x, that's going to be y. So because this is 0, we know that this plane is going to contain the y-axis, the one that's missing. Now, you may have learned, I don't know, that a plane is determined by a line and a point not on the line. So what we need to do here is come up with a value for x, a choice of x and z that will make this equal to 0, because we're just looking for some point that is not on the y-axis. And I can't do the intercepts in this case. That isn't going to work. So I can look at that and see that if I choose 1 for x, I can choose anything I want for y, but I'm going to pick 0 to make things simpler. Then if I choose 2 for z, then 2 times 1 is 2, minus 2 is 0. That will be a true statement, so that point is on the plane. So let's see, I'm going to plot the point 1, 0, 2. So here is 1, and then 0, and then 2 is going to be up here. Now I'm going to try to show that point. Here's your visualization skills. So I'm going to make this come up parallel to the z, and I'm going to make this come out parallel to the y. So this point right here, sitting out in front of your paper, trying to give you perspective there, is our point 1, 0, 2. Now our plane is going to contain that y-axis down here. So in particular, I'm going to connect this there because the origin is going to be in our plane because we're containing the y-axis. Now I don't know if you can visualize that, but I'm going to try to show that that's coming out from the y-axis there. So our plane is there going back down into the paper there. So this thing is at an angle going down into the paper. These I think are really tough to visualize. I'm trying to show you in class with where I can hold up an object and try to show it to you, and hopefully that'll help. So let's do another one. Let's do z equals 0. So now, in this case, I'm going to draw our axes here. So there is going to be our x, there is our z, this is our y. Now, because we're missing both x and y, this will contain both the x and y axes. So if it contains the x and y axes, that it means it is the xy plane. So that means it's going to look like, see if you can visualize this, oops, that it's going to come out here parallel to the floor, and so it's containing the x and y axes. It is this plane that's supposed to look parallel to the floor. I'm going to stop this video here and then make a part 2.